Hello, my name is Elizabeth, and today I'm going to be talking about Graham's number, one of the largest notated numbers in science and mathematics today. Now, before I can talk about how humongous Graham's number is, I have to talk about the uncommon notation used for it, because it is too large to use common day notation. So, let's start with multiplication. A times B is A plus A plus A, B number of times. The next level up is exponentiation. A to the power of B is A times A times A, B number of times. And then the next level up from that is Knuth's up arrow notation. A single up arrow is equivalent to exponentiation. You have A single up arrow B, A to the power of B, A times A, B number of times. When you have two up arrows, you have A double up arrow B, you have A to the power of A to the power of A, B number of times. And so you can see how with increasing number of up arrows, the magnitude just skyrockets. So Graham's number uses this notation in a pyramid, where each following level of the pyramid has the number of numbers that was the solution to the previous level. So if the first level is 3, then the second level is 3 to the power of 3, 3 times. So the second level is 3 to the power of 3 to the power of 3, which is 7.6 trillion. And the third level is 3 to the power of 3, 7.6 trillion times, which is hard to calculate on its own. And so the fact that this is the third level and Graham's number is the 64th level of this pyramid begins to explain just how hard it is to notate such a huge number. But it is 64 up arrows, 3. So how do we conceptualize this? I like to use grains of sand. If you have a beach of grains of sand, sure, that's a lot of grains of sand. But what if you had an entire planet Earth made out of grains of sand? That's a lot more, right? And then if you turn each of those grains of sand, the planet of grains of sand is now planet-sized grains of sand. And each of those planet-sized grains of sand you make out of sand, and you counted all of those grains of sand, you would still not have enough grains of sand to represent Graham's number. Irrational numbers are notated with a ... at the end because it's possible that they go on infinitely. So pi is 3.14 ... because it could go on forever. Graham's number is notated with a ... at the beginning because it's not actually known what number it starts with. All that has been calculated is approximately the last 500 digits. It's not even known how many digits there are. It's just known that it ends in ... 195387. And that to me is fascinating.